Okay, so good morning class. Today we will be discussing our first discussion in foundation engineering and retaining wall design. Okay, so our first topic is compressibility of the soil. So the outline of our discussion first is the fundamentals of consolidation. Okay, number two is a one-dimensional laboratory consolidation test. The three is the void ratio and pressure plots. Four, calculation of settlement from primary consolidation. The compression index and the swell index. The calculation of settlement from secondary consolidation, time rate of consolidation, the coefficient of consolidation, and the coefficient of volume compressibility and permeability. Okay, so first dito tayo sa fundamentals of consolidation. Okay. So, when a saturated soil layer is subjected to a stress increase at the ground surface, so ibig sabihin, may pagbabago yung stress dun sa top ng soil layer. So, ang mangyayari, yung pore water pressure is mag-i-increase suddenly. Okay? So, in the case ng sandy soil, so drawing ko lang yung sandy soils. Let's say this one, ito yung soil, okay, sandy. So, medyo parang ganyan-ganyan lang yung soil particles. Okay? So, medyo may voids pa rin naman siya ng konti. Since, yan. So, for example, this one. So, in sandy soil that are highly permeable, as you all know, since sandy is highly permeable yan, so madaling mag-flow through yung water dito. Diba? So, at the time na may stress increase at the top or at the ground surface, okay, yung increase in the pore water pressure is completed immediately. So, mabilis siya matapos. So because of that, rapid drainage, the pore water in the sandy soil, elastic settlement lang yung mangyayari dun sa ground surface. However, in the case of saturated clay soils, since yung clay soil, this one is for sand. Take note ha, this is saturated soils. So for the clayey sands, ito, this one. So compared to sand, yung soil, yung parang soil particle niya is parang mas dikit-dikit. Mas close enough to each other, diba? So, and let's say, yan, dikit-dikit yan. Yan. Yan, medyo this one. Yan. Yan. So yung when the water, yung mag-flow yung water dyan, paano mag-flow yung water sa clay, medyo mas mahihirapan siya compared to sand since yung hydraulic conductivity ng clay is significantly smaller than that of the sand. Okay? So mas mahirap. So ulitan ko lang yung yan, medyo mahirap. So medyo mahirap yung pag-flow ng water compared to sand. So in the case of saturated clay. Okay, so the excess in the pore water pressure generated by that loading, by that stress increase, gradually dissipates over a long period of time. So medyo matagal mag-dissipates yung pore water pressure excess because dun sa clay soil, yung hydraulic conductivity niya compared to sand is much smaller. Okay? So a consolidation refers to the compression or settlement that soils undergo as a response of placing loads onto the ground. Then also, a consolidation is a time-dependent process. So in some soils, it may take us a long of 100 of years to achieve a complete settlement. So in general, yung clay undergoes a consolidation with time and yung sand settles very quickly kasi nga 'di ba yung hydraulic conductivity ng sand is much higher compared to clay. So therefore, we only considers consolidation in clay. Yan. Kasi nga hindi agad-agad natin mapapansin yung consolidation settlement dun sa kapag may clay layer tayo dun sa soil profile natin. So minsan, 'di ba ang sinasabi nila nagkakaroon pa ng settlement yung lupa natin. Totoo 'yun, nagkaka-settle pa 'yan. Kasi nga hindi pa kasi nga may clay layer ka sa ilalim, hindi agad nagfo-flow yung water doon since nahihirapan siya, parang nai-enclose pa siya. So hindi siya nag-squeeze out agad-agad. Okay? Yung compression is caused by deformation of the soil particles, relocation of soil particles, and expulsion of water or air from the void spaces. Okay, so consider the case where a layer of saturated clay thickness H that is confined between two layers of sand. So ito yung clay natin. So para mas madali nating maintindihan, let's say ito yung clay natin. Confined siya with sand layer sa taas and sand layer sa baba. Okay. Then there is a groundwater table at this location. Okay, groundwater. So ibig sabihin saturated tong sand, yung clay, then yung sand din sa ilalim. So it is being subjected to an instantaneous increase of total stress, delta sigma. May change in stress dun sa taas. So maybe due to backfilling, due to building structure, the weight of the building structure or backfilling. So that is the total stress at the top. Okay. So consider natin as a spring model yung saturated clay natin. So kuha tayo ng isang soil sample dito. Kuha tayo dyan. Yan. So that is an laboratory setup. Okay. So at time t equals 0, the valve is closed. Saraduhan muna natin yung valve sa taas. Take note, the valve is closed. So no instantaneous delta sigma is applied at top. So therefore, yung stress or yung change in stress at the bottom of this location of the clay, our soil sample is 0. Okay. Then at the time na nag-apply tayo ng force P at the top, and this one, force P at the top. So the change in stress at the bottom or at this location is equals to P over A. So that is 100% of that change in stress because the valve is closed. Yeah, valve is closed. Okay. However, when the valve is open, this is the time na nag-i-start na mag-flow yung water dun sa clay. Ayan, mag-flow yung water dun sa clay. So nag-i-start na siya. So gradually bumababa yung stress at that location. So kung mapapansin nyo, delta U is less than P over A. Gradually yan pababa ng pababa. So kung mapapansin nyo rin ito, yung soil na to, pababa rin to ng pababa. Yan, yung soil thickness na to, pababa rin yan ng pababa. So after some time na complete na yung settlement or complete na yung pag-flow ng clay, ng water dun sa clay, ang mangyayari yung since the valve is open, so tatapon yung mga water dito. So at complete consolidation settlement, so yung delta U is approaching to 0 and nagsettle na siya. So this one, yung length na to or yung distance na to or tinatawag natin na delta H or change in elevation is the consolidation settlement. Okay? So do you have questions for this class? Wala naman. Sige, tuloy ko lang. Okay. So meron kasing word na parang nalilito sila what is compaction and consolidation. Para kasi nai-interchange yung dalawang word na to eh. So compaction versus consolidation. So yung compaction, that is instantaneous process and that is applicable to all soils. Okay. However, dito sa case ng consolidation, this is time-dependent process applicable to clay soils only. Only the clay soils is yun lang yung nagka-consolidate. So it can occur over hundreds of years. Yan. Ito yung consolidation. So for the compaction also, that is applicable to unsaturated soils. This one, unsaturated soils. and decrease in the air voids, not in the water voids. However, for consolidation, that is only applicable to saturated soils. There is a decrease in water voids and the air voids does not exist. Okay. Then lastly, dry density increases as the water content does not change. And for consolidation, yung dry density naman is nag-increase. However, the water content decreases. Okay, so that is compaction versus consolidation. So there are also three types of consolidation. We have the immediate consolidation, the primary consolidation, and the secondary consolidation. So yung immediate consolidation is like a compaction settlement. So it was caused by elastic deformation of dry soil or moist and saturated soil without the change in the moisture content. So parang ano to elastic pa siya. So elastic deformation. So pwede siyang mag-swell up pa. However, in the case of consolidation, primary and secondary consolidation, for the primary consolidation, it is caused by result of volume change in saturated cohesive soils and due to the exclusion of water occupied in the void spaces. So the same scenario dun sa cylinder setup natin sa laboratory kanina. Okay. However, in secondary consolidation, it occurs in saturated cohesive soil as a result of a plastic adjustment of soil fabrics. So ito, yung secondary consolidation is mas matagal compared to the primary consolidation. So unang mangyayari primary consolidation, next is secondary consolidation. Since kasi di ba dito, meron kang exclusion of water void spaces. So mag-a-adjust yung soil mo niyan since wala na yung water doon sa nabawasan yung water doon sa isang layer, di ba? So mag-a-adjust yung soil diyan. So due to that adjustment through time, so maybe 100 of years, 10 years, at any time t. Okay. So due to the adjustment of that soil, since may load pa rin sa taas, mag-a-adjust yung soil dun sa baba, di ba? Since nawala na yung, nabawasan yung spaces, di ba? Parang na-exclude yung water. So, that is a secondary consolidation due to the adjustment of soil fabrics. Okay. So, let us consider deeply naman when comparing dun sa total stress increase, pore water pressure, and effective stress. Diba? If natatandaan nyo in your geotechnical engineering 1, okay, we all know that total stress is equals to the pore water pressure plus effective stress. Diba? Total stress is equals to the pore water pressure plus effective stress. Okay. So same setup, consider a delta sigma as stress increase at the ground surface. A clay layer is confined with sand at the top and sand at the bottom. Then a groundwater table at the top of the clay. Okay. So the total stress increase at time t equals 0 is this one. Since the total stress increase is syempre, yung change dun sa total stress is delta sigma. Therefore, yung time t equals 0, yung the change in the pore water pressure is equals to delta sigma then. And the effective stress is 0. Wala pa. Now, when time equals to 0 to positive infinity, so yung total stress increase is the same. Yan pa rin dapat yun. Then, at time t equals 0, yung pore water pressure, this one is yung clay, top of the clay layer. This one. Ito yung top of the clay layer since that is H. Ito yung mid ng clay layer. Ito yung bottom of the clay layer. Okay. So at the top of the clay layer, this one, nandito yung location na yun. That is 0. Then at the middle, dun yung mataas yung pore water pressure. Bakit? Kasi yung sa middle portion, mas malayo yung flow of water niya para dissipates yung water dun sa clay. So mas malayo yung travel niya. So ito yung pinaka farthest distance in the clay layer, yung gitna, 'di ba? Syempre, at the top and at the bottom, yung gitna yung pinakamalayong distance. So therefore, yung pore water pressure at the middle of the clay is highest. Yun yung highest. Then the effective stress is equals to this graph. So kung mapapansin nyo, kapag pinag-add natin to and ito, this is equals to this total stress. Then ito, pag pinag-add mo dito, is this one. Okay? So, ayan. So, mapapansin natin that the total stress is equals to the pore water pressure minus the plus the effective stress. Now, at time t equals infinity, or let's say a complete settlement, okay, delta H is equals to delta sigma. This one is the total stress increase equals to the pore water pressure now equals to 0 since complete na yung settlement. The delta U is equals to 0, and the effective stress increase is approximately equal to the total stress increase. So, ang mangyayari, darating yung time na mag-equilibrium na yung total stress and the effective stress naman. So, at time t equals 0, silang dalawa yung mag-equal. And complete settlement, yung effective stress and total stress naman yung equal. Okay? So next natin is the one-dimensional laboratory consolidation test. So paano ba na nagka-conduct ng laboratory for the consolidation test? So unfortunately, parang hindi yata kasama sa course na yung laboratory work for foundation engineering or geotechnical engineering too. So sayang. Pero if you want to study, you can check sa YouTube naman for the one-dimensional laboratory testing for consolidation test. Okay. For one-dimensional laboratory consolidation test, so ginagamitan siya ng odometer. So kung nakapunta na kayo dun sa laboratory natin sa CE, meron doon odometer. So, ganito yung itsura ng odometer. So, ang ginagawa doon, kukuha ng soil specimen, clay soil specimen. This one is yung porous stone at the top and porous stone at the bottom. So, same setup doon sa case na meron tayong clay, then merong permeable soil layer at the top and permeable soil layer at the bottom. Okay? So, maybe sand at the top, sand at the bottom. Okay, so dadaan siya ng different stages. So, mangyayari dito, yung load na i-apply dito, change gradually, and i-record yung dial gauge. So, stage 1, initial compression, restored voids ratio E sub 0 of the soil sample at the depth of the test. Then, stage 2, yung volume of deformation comes from squeezing out the water from the soil pores. And the stage 3, where consolidation, secondary consolidation, iniiwan namin yan nung time namin. So let's say days lang. Let's say 1 week namin itong iiwan. And titingnan namin if magkakaroon ng another settlement. So that is the secondary consolidation. So volume deformation comes from crushing of the soil particles and the adjustment of the soil fabrics. So, ayun. Ganyan yung pag-set up para malaman kung ano ba yung consolidation test doon sa soil layer na yun. Okay. So, the four most important soil parameters determined in the consolidation test are the pre-consolidation pressure, or the sigma C prime, okay, denoted as sigma C prime. So, the pre-consolidation pressure is the maximum. Okay, take note, this is the maximum stress that the soil has experienced in the past. Okay. Then the compression index, this indicates the compressibility of a normally consolidated soil. So in other words, this is the slope of the E log sigma plot, or the slope of the graph of a normally consolidated soil. So this indicates the compressibility of a normally consolidated soils. And the Swell Index, denoted as C sub S or CS, which indicates the compressibility of over-consolidated soil. So later you will determine what is normally consolidated and over-consolidated soil. Then, and next is the coefficient of consolidation, C sub V or CV. So this indicates the rate of compression under a load increment. So this will tell you kung at ilang time ba magkakaroon ng 60% consolidation or 100% consolidation. So that is the coefficient of consolidation. Okay? So after doing the odometer test or consolidation test, so you will plot your your data. So that is a void ratio pressure plots. Okay. So yung void ratio pressure plots is, for example, we have the specimen area. So the same specimen area with initial height h. Okay. So now, yung specimen natin, we can arrange that to a soil solids and a voids. Okay? So, paghiwalay lang natin kunwari na hindi natin siya paghiwalayin in actual, pero we can compute what is how much is yung solid and how much yung sa voids. Okay. So calculate H sub S or the height of the solids. So height of the solids is equals lang yan sa the dry weight of the specimen over area times the specific times the unit weight of the soil solids. This one. So GS times gamma water, that is equals to the height of the solids. Okay. So we can compute the height of the solids. This one, H sub S. Then the initial HV or the height of the voids is just simply the total height H minus yung height of the solids. Okay, so nakompute natin yung HV and HS. So calculate the initial void ratio. So by definition of the void ratio, if you recall, that is the ratio of the volume of the voids versus the over the volume of the soil solids. So plugging in the value of volume, 'di ba? Ano ba yung volume, 'di ba? Area times H lang yan. So since they have the same area, since isang soil specimen lang to. So they have the same area, therefore matitira is HV over HS. Okay. Then, for the first incremental loading, sigma 1, ito yung initial stage, let's say stage 1. Okay. Which causes deformation delta H1. So calculate the change in the void ratio, delta E sub 1. We can say that that is equal to delta H1 over height of the solid. So parang VV over VS pa rin, pero change na lang yung ginawa. So that is change H1 over HS. H1 is this one, yung unang settlement. Yan, yung due to the stress sigma 1. Okay. Next natin is calculate the new void ratio E sub 1 after consolidation caused by the pressure increment sigma 1. Since parang stage 2 na tayo, i-increase natin gradually yung sigma, yung stress. So magkakaroon pa ng panibagong change in H, that is change in H2. Yan. So we can say that to calculate the new void ratio after consolidation caused by the pressure increment sigma 1. So E1, E sub 1, new void ratio natin, since is equals to, syempre, the initial void ratio E sub 0 minus yung change na na-compute natin kanina. So ito yung magiging new void ratio mo at increment sigma 1. Okay? Next. So, next loading, sigma 2. So, ito na siya. Equals din siya sa E1. Then, this one is change in H2 minus HS. Okay? So, ayan. So, that is the void ratio relationship. So, plotting the values. So, void ratio, we have E sub 1 at sigma effective pressure sigma 1 and E sub 2 at the effective pressure sigma 2. Okay. that is plotted in a log scale. So log tawag dito log yung relationship ng void ratio and effective pressure. So that is a log scale. So C sub C is the slope of the plot for normally consolidated soil. Take note, this is for normally consolidated soils. Okay. So, syempre, the C sub C or the compression index is change in Y over change in X. So, change in Y is E sub 0 minus E sub 1 over change in X, that is log of change in delta or change in sigma or change in effective stress plus the original effective stress or overburden pressure. Minus the log of overburden pressure is equals to delta E over log of effective stress or the overburden pressure plus delta sigma or the induced pressure at the top or at the ground surface over the overburden pressure. So that is compression index. This will tell us ano ba yung change between the for normally consolidated soils. So, kanina ko pa sinasabi what is normally consolidated and over-consolidated. So, normally consolidated soils is this one is a type of consolidation where the present effective overburden pressure or the present effective stress is maximum to which the soil has been subjected in the past. Ibig sabihin, yung effective stress at the middle of the clay layer is greater than or equal to the pre-consolidation pressure. Yung pre-consolidation pressure, yun yung pinakamataas na naramdaman niya in the past. Pinakamataas na effective stress na naramdaman niya in the past. So, yan yung pre-consolidation pressure. So, since nag-normally consolidated soil ka, yung new effective overburden pressure mo, then after next year naman, siya na yung magiging pre-consolidation pressure mo. So, parang pinaltan niya na lang yung pre-consolidation pressure mo. Okay? That is yung that is the case for normally consolidated soils. Okay? So normal lang na napapaltan yung yung pre-consolidation pressure. However, sa case naman ng over-consolidated soil, so ibig sabihin hindi na lampasan ng present effective stress or present effective overburden pressure yung past pre-consolidation pressure. So yung tinatawag natin na maximum effective past pressure yung pre-consolidation pressure. So ibig sabihin hindi na lampasan ng present yung past mo. So ang sakit naman nun. So hindi na lampasan ng present yung past. So that is over-consolidated. So ibig sabihin over pa yung pre-consolidation pressure. Okay, so the past effective pressure cannot be determined explicitly because it is usually a function of geological process and consequently it must be inferred from laboratory test results. So maybe you wonder paano ba mako-compute yung pre-consolidation pressure kung wala naman kaming history ng wala namang history dun sa isang lugar ng pre-consolidation pressure. Wala namang nag-conduct ng geotechnical report dito. So, paano ba hahanapin yung pre-consolidation pressure na yun? So, to determine the pre-consolidation pressure, okay, Casa Grande 1936 proposes a simple graphical construction to determine the pre-consolidation pressure from the E-log plot. Okay, remember yung E-log plot natin kanina sa laboratory? The effective pressure and the void ratio. So yung graph na yon by visual observation, established na yung point A at which the E-log plot has the minimum radius of curvature. So hahanapin dyan yung minimum of radius of curvature. So, ibig sabihin, saan dyan may pinakamaliit na R? This one. Point A na yan. So, at establishing a point A, so, Casa Grande, draw a horizontal line AB. Okay? Horizontal line AB. Then, draw a line AC tangent to point A. So, ito yung point A, draw a line tangent to the graph of this one. That is AC. Okay? Then, draw a line bisecting the the line AB and AC. So, drawing ka dun sa gitna nila. That is line AD. So, equal yung angle alpha, alpha. Then, project a straight line portion GH yung this one, project ka ng line dito of the E-log plot back to the intersect of AD. Okay, at F, and the abscissa of point F is the pre-consolidation pressure. That is, we get the pre-consolidation pressure or the effective stress determined by the Casagrande observation. Okay, then there is a ratio for OCR, for overly consolidated soil. We call it the over consolidation ratio. It's just simply the ratio of your pre-consolidation pressure to the present overburden or present effective stress. So simply divide mo lang tong past over the present. Past effective stress over the present effective stress. Okay. Then the calculation of settlement from primary consolidation. Since all the preliminary investigation is okay na determine na natin yung preliminary investigation or given data, we can now solve for the calculation of settlement from primary consolidation. Okay, so we only consider primary and secondary consolidation. Okay, so for the consolidation of a clay. So punta muna tayo sa primary consolidation. Okay, so calculation of settlement from the primary consolidation, we are dividing that to 3 categories. So number 1 is yung one layer or one dimensional lang. So laboratory testing lang to. One dimensional lang. Next is normally consolidated soils and over consolidated soils. So dito muna tayo sa calculation of settlement from one-dimensional primary consolidation. So let us consider a saturated clay thickness of H, the cross-sectional area A. Then average effective overburden pressure sigma prime O. So please note na lang yung notation for the effective overburden pressure or effective stress is sigma prime sub O. Okay. Because of the increase of pressure delta sigma at the ground surface, so we let the primary settlement notation be equal to S sub P, settlement primary. So primary settlement. So at the end of consolidation, delta sigma is equals to delta sigma prime. Ito yung stress at the top. Thus, the change in the volume given in this figure is equals to change in volume, syempre, the original volume minus yung V1. Whereas yung nag-change na yung height H. So, original volume, ano ba yung formula? That is H times area lang. Minus yung new value of H, that is H minus SP or the primary settlement times the area. So, distribute HA. Okay, distribute mo yung HA. So, ang natira na lang, so magka-cancel out yung HA. So, ang natira is SPA. Okay, or the change in volume. The primary settlement times area. That is equation 1. Now, V sub 0 and V sub 1 are the initial and final volume changes. However, the change in total volume is equal to the change in volume of the voids, delta VV. Okay? Just like yung ginawa natin sa pressure, void ratio pressure plots, di ba? Thus, that the change in V, which is given from equation 1, SP times A, is equal to the change in volume of voids. Okay? So, hindi naman nabawasan yung solid particles. Yung volume of voids lang yung nabawasan, di ba? So, V sub V at time initial or V sub V0 and V sub 1 is the initial and final void volumes. respectively. So from the definition of the void ratio, we have definition of the void ratio, recall E is equals to volume of the voids over volume of soil solids. So that is equals din siya kapag change in E, therefore that is change in volume of voids over change in volume of solids. So we have this equation 3. Okay? So therefore, V sub S naman natin, if you recall the formula for V sub S or the volume of the soil solids, that is equals to the original volume divided by 1 plus E sub 0 or the void ratio, the initial void ratio. That is the volume of soil solids. So V sub 0, that is equals to A over H, that is uh, AH over 1 plus E sub 0. That is our equation 4. Okay, so E sub 0 is the initial void ratio at the volume V sub 0 or initial volume. Okay, now from equation 1, 2, and 3 and equation 4, we get this equation. So delta V, kunin mo yung delta V which is SP times A, delta which is yung delta V is now equal to delta E Vs, which is Vs is equal to the equation 4 AH1 over 1 plus E sub 0. We get this relationship. Okay, so factor divide all terms by A. Now we get the formula S sub P, or the primary settlement S sub P, is equals to H multiplied by delta E over 1 plus E sub 0. Okay, this is your settlement formula for one layer or one dimension primary consolidation. Okay, this one. Next natin is calculation of settlement for normally consolidated clay. So remember, di ba, may normally consolidated and over consolidated. Okay. So normally consolidated clay, this is the time na yung past is equal or greater than yung present is equals or greater than the past effective pre-consolidation pressure or yung maximum effective stress, di ba? Yun yung normally consolidated clay. So from the plot kanina, the E-log plot, that is C sub C or the compression index or the slope of the E-log plot, E-log sigma prime plot relationship. So delta E, we can now solve delta E is equals to C sub C compression index log of sigma prime overburden pressure plus the induced effective stress at the ground surface over the effective overburden pressure. So plugging into equation 1, so delta E pag-plug in dito, okay? So we now have the formula for ito. Plug in nyo lang yan dito, class. So one layer consolidated S sub P. So change nyo lang yung delta E to get this equation. That is primary consolidation settlement. So the C sub E is the compression index, E sub 0 is the in situ void ratio, H is the thickness of the clay layer, sigma prime sub O is the effective pressure, and delta sigma prime is the added stress at the ground surface. Okay, yan yung calculation of settlement for normally consolidated clays. For the case naman ng over-consolidated clays, we have two condition or we have two cases. Okay? So since ang over-consolidated clay is yung past ay yung present is hindi napunan yung kakayahan ng past, ba? Mas malaki pa rin yung nasa past. So mas malaki yung effect yung pre-consolidation pressure or yung maximum effective stress at the past na na-experience niya compared to the present effective overburden pressure. So yung ang slope naman natin ngayon, we denote the slope of the E-log plot C sub S. So yung C sub S is the swell index. So, same formula for this scenario. Bago lang plus ng notation. Naging C sub S na lang siya. So, change, same pa rin yung formula for delta E. Delta E or the change in void ratio is equals to C sub S log of effective overburden pressure plus the induced pressure minus the logarithm of effective overburden pressure. Okay, so for condition 1, in condition 1, for overly consolidated clay, ito yung time na yung effective overburden pressure mo plus the induced pressure at the ground surface is less than or equal to the pre-consolidation pressure. Mas malakas pa rin yung pre-consolidation pressure. Mas mataas pa rin yung pre-consolidation pressure. So the formula for S sub P or the primary settlement is equals to C sub S times H over 1 plus E sub 0 logarithm of effective overburden pressure at the present plus induced pressure at the ground surface over the effective overburden pressure at the present. So that is S sub P, this one. Almost the same siya ng equation na to. So, panaltan lang yung ratio ng notation na C sub S. Yung ratio C sub C or the compression index ng C sub S. Okay. For condition 2 naman, this is the time na yung effective overburden pressure mo plus the induced pressure at the ground surface is greater than the pre-consolidation pressure. So the formula is simply equals to C sub S times H over 1 plus E sub 0 or the initial void ratio logarithm of pre-consolidation pressure over the present effective overburden pressure plus C sub C or the compression index times H over 1 plus E sub 0 or the initial void ratio multiplied by the logarithm of effective overburden pressure plus the induced pressure at the ground surface over the pre-consolidation pressure. So basically, formula based lang tong primary consolidation. So you need to determine lang kung normally consolidated ba siya, over consolidated with condition 1 or condition 2, or for one layer lang yung kino-consider. So that is the case nito. Okay? So, ang ibig sabihin pala class ng one layer is one layer of clay lang yung consider. Walang sand sa taas, walang sand sa baba, and laboratory. Parang laboratory work to halos. Okay? So, that is the 3 cases for the calculation of settlement. Now, kung mapapansin nyo, meron tayong value na C sub C and C sub S. So, what is C sub S and what is C sub C? So, kunwari hindi nag-conduct ng laboratory testing. So, pwede mo pa rin bang ma-compute or ma-determine yung value of compression index and the swell index? Compression index is the slope for normally consolidated soil and the swell index is the slope for the overly consolidated soils. Okay. So, for the compression index, Skempton 1944 suggests empirical impression for the compression index. So compression index can be determined by graphic construction after obtaining the laboratory test for the void ratio and pressure plot. However, in the case na hindi siya available, you can use the formula by Skempton in 1944. This is for undisturbed clay, where equals to C sub C is equals to 0.009 LL or the liquid limit minus 10. Then for remolded clays, ibig sabihin, na-disturb na yung clays or na hukay, parang nahukay na yung clay, then ibinackfill lang, that is for remolded clays. So for the remolded clay, that is C sub C is equals to 0.007 multiplied by the liquid limit minus 10. So take note that in the absence of laboratory consolidation data, Skempton equation is often used for an approximate calculation of primary consolidation in the field. So in our problem, in our example problem, kapag hindi given hindi sinabi na remolded clay, the default assumption is undisturbed yung clay. Take note of that. Pero pag the case naman na backfill, kunwari na cut yung isang clay layer, then ibinalik, that is a remolded clay. Okay, so this one is yung default C sub C natin. Okay, next natin is the swell index. For the swell index, smaller in magnitude than the compression index and generally can be determined from a laboratory test. So many researchers determine the value of C sub C and C sub S, and they notice that the value of C sub S is equals to or approximately equal to 0.2 to 0.3 of the compression index. So for conservative, we will take C sub S is equals to 1/5 of C sub C. So ito rin yung ginagamit nung examiner natin sa geotechnical engineering, na the value of C sub S kapag hindi given is 1/5 of C sub C or the compression index. So table below is the value na many researchers determine the value of C sub C and C sub S. So this one, and for the value for the correlation of compression index, and this one is for the swell index. So if you want a topic for a thesis or suggest a topic in a thesis in geotechnical engineering, maybe you consider determining the value of compression index and swell index. Okay. So calculation of settlement from secondary consolidation. So for secondary consolidation naman, ito yung time na mag-a-adjust na yung soil fabric natin. So since na squeeze out na yung karamihan ng water, mag-a-adjust yung soil fabric. So ito yung tinatawag na secondary consolidation. Okay. So for the calculation of settlement from the secondary consolidation, so following the primary consolidation, some settlement continue to rearrangement of the solids in the soil. This stage is called secondary consolidation. So from the plot of time and a void ratio log scale, yan. So time naman yung kino-consider dito since ang pag-a-adjust ng soil solids or soil particles is medyo matagal. So through time talaga yung pag-a-adjust nila. Okay. So the slope is denoted as C alpha. Okay, yung C alpha is equals to the change in E over the log T2 over T1. Okay, so simply that is the slope of the graph. Okay, so the secondary compression index can be determined from the formula C sub alpha. So yung secondary compression index is denoted as C sub alpha. So that is delta E over log T2 over T1 or delta E over log T2 minus log T1. So C sub alpha is the secondary compression index, delta E is the change in void ratio, and T1 and T2 is the time. So T2 and T1 are times. So the magnitude of the secondary consolidation settlement can be calculated as S sub S is equals to yung secondary consolidation settlement is denoted as secondary consolidation settlement. So S sub S. Okay. Then that is equals to C sub alpha HP over 1 plus T sub P log T2 over T1. So ano yung mga notations na yun? C sub alpha is the secondary compression index. The time T2 and T1, yung time T1 is the time for completion of primary consolidation. So ito yung time na complete yung primary consolidation. And yung T2 is yung time after completion of primary settlement where settlement is required. So kunwari, ang gusto mo, let's say the time na na-complete yung primary consolidation is 1.5 years and you want to determine ano ba yung settlement after 10 years. Okay, so you can solve for that secondary settlement T, letting T2 equals to 5 years or 10 years. 10 years for example, 10 years. Okay, so for the void ratio, E sub P, that is the void ratio at the end. Take note, void ratio at the end of the primary consolidation. So, since nag-primary consolidation na, complete na yung primary consolidation, syempre magbabago na yung initial void ratio mo at that time na mag-start na yung secondary consolidation. So yung gagamitin na nating void ratio is equals to E sub P. Whereas E sub P is the initial void ratio of the clay layer minus the delta E, yung change in the void ratio. Okay, then the formula HP, the notation HP is the thickness of the clay layer at the end of the primary consolidation. So, for example, yung original height of the clay layer is 3 meters and after completing the primary consolidation, nabawasan siya ng 10 meters. So, ibig sabihin, 10 mm. So, ang gagamitin nating value of H sub P is 2,990 millimeters. So, that is the cases. So, yung thickness of the clay layer at the end of primary consolidation. Then, next is S sub S is the secondary consolidation settlement. Okay, so for the time rate of consolidation, you can determine the time kung kunwari 100% settlement or 100%, 60% settlement, malalaman natin o makocompute natin kung anong time ba yon mangyayari. Okay, that is the time rate of consolidation. So the time required to reduce the excess pore water pressure is primarily a function of the distance of the water that must travel to exit the stress area. And so in this figure, the clay stratum is sandwiched between two layers of sand. So the farthest distance of the water particles must travel to escape the pressure is H over 2. Okay? Yan yung sinabi ko kanina that yung farthest distance to escape the clay layer is at the middle of the clay. So for the time factor, this is the non-dimensional number. So TV or the time factor, so that is equals to CV or the coefficient of consolidation times T all over the thickness of the drainage layer. So H over 2 for two-way drainage. So may drainage sa taas, may drainage sa baba. Pupunta yung soil sa taas, pupunta yung soil sa baba. And HDR for one-way drainage or isa lang yung permeable layer na. And U is the degree of consolidation. Okay? Yung T na to, that is the time rate of consolidation. This is the yung time kung gusto mong malaman kung anong time ba siya, consider mo kung anong time mo ba gusto malaman yung ano yung degree of consolidation at that time. So for U, from 0 to 60% of degree of consolidation, ibig sabihin 60% na yung natapos doon sa consolidation, between 0 to 60%, the value of your T sub B or the timing factor is equals to pi over 4 U in percent over 100 squared. So para siyang area lang ng circle, di ba? So T is sub B is equals to pi over 4 U in percent over 100 squared. Then for degree of consolidation greater than 60%, the formula is T sub V is 1.781 minus 0.933 log of 100 minus U in percent. Okay, that is the time factor. So we can also use the graph, the table, this one. If you don't want to use this equation, pwede ditong sa graph na lang. So T sub V and U is given. So the value of U and the value of T sub B or the time factor is written from 0 to 100. So basically, kung ano yung nakalagay dito, yun lang yung ginamit dito. So tinabulate na lang. Okay? So you can verify. Parehas lang yan. Okay. So for the time factor, T sub B provides a useful expression to estimate the settlement in the field from the results of a laboratory consolidation. So the time at the field over the time at the lab is equals to the height of drainage in the field is squared over the height of drainage in the lab squared. Basically, that is equals to T1 over T2, U1 over U2 squared. So therefore, the degree of consolidation is settlement of the layer at time T and S sub over S sub B at the ultimate settlement of the layer from primary consolidation. So that is the degree of consolidation. So last topic is the coefficient of consolidation, C sub B. Okay? So, kung mapapansin nyo, you have the value C sub B dito. So, yung TV is the time factor. We can get the TV. We can get the time, time rate of consolidation, yung gusto nyong time na ma-compute. Okay, HDR is the thickness of drainage of layer. So, H over 2 on H or one way and two way and one way respectively. So, what is the value of CB? So there are two graphical methods for getting the value of coefficient of consolidation CB. So you can use logarithm of time method by Casagrande and Fadum in 1940 is given written in this by this formula, and pwede rin yung square root of time method by Taylor in 1942 written by this formula. So take note that T sub 90 is the time for 90% consolidation, and T sub 50 is time for 50% consolidation. Okay, that is this value of C sub V. So coefficient of volume compressibility and permeability. So this one tells us kung ano ba yung coefficient ng pagko-compress ng volume, or yung gaano ba kabilis nagko-compress yung volume natin ng clay layer natin. So the notation for coefficient of volume compressibility is denoted as M sub B is written in this formula, whereas A sub V over 1 plus E average, whereas yung A sub V mo is delta E plus delta sigma, or the induced pressure at the top. And E average is E plus E sub 0 over 2, or the average of the void ratio. Then the coefficient of permeability is equals to K is equals to C sub B times MV times the gamma water. Then that is K, hydraulic conductivity or coefficient of permeability, MB or the volume of compressibility, and gamma water is the unit weight of the water. Okay, so that's it for our discussion for compressibility of the soil. So for the reference, you can check Das and Sivakugan, Fundamentals of Geotechnical Engineering and Introduction of Geotechnical Engineering by Holtz and Kovacs. Okay, so do you have questions, class? 2 minutes na lang. Okay. May question ba, class?